The Northrop P-61 Black Widow was the only American aircraft of World War II designed from the ground up as a dedicated night fighter. It also went down in history as the largest and heaviest fighter to serve with the United States Army Air Forces during the war. This formidable aircraft first entered combat in the South Pacific in the summer of 1944. It became the standard American night interceptor during the final stages of the war. Unlike famous day fighters like the P-47 Thunderbolt or the P-51 Mustang, the P-61 did not rack up a massive number of aerial victories. The reason was simple. By the time it arrived at the front in significant numbers, the Allies had largely swept the skies clean. Enemy pilots rarely dared to fly after dark. This unique aircraft was developed by an engineering team led by Jack Northrop. The company he founded bore his name and got its start in August 1939. Northrop served as both president and chief engineer. By the following year, the company had rapidly expanded. They moved into a new 122,000 square foot manufacturing facility in Hawthorne, California. At the time, they had just over 100 people on the payroll. Initially, they worked as subcontractors for other major aviation manufacturers. They built tail sections for the famous PBY Catalina flying boats and engine nacelles for B-17 heavy bombers. The company also assembled Vultee Vengeance dive bombers for the British under-license. This early production work eventually paved the way for the engineering team to create their most successful aircraft of the era. The story of the P-61 began in early 1940, when company representatives arrived in London to discuss aircraft production. At the time, the Luftwaffe had begun relentlessly bombing British cities under the cover of darkness. The Royal Air Force simply lacked the equipment to turn back these nighttime raids. Day fighters like the Spitfire and the Hurricane were intercepting enemy bombers far too late. This usually happened after the Germans had already dropped their bombs. Britain desperately needed a dedicated night interceptor. They issued a request to several aircraft manufacturers, and Northrop was among them. The British requirements for the new aircraft were highly demanding. The proposed fighter had to patrol the skies all night. It needed to loiter for at least 8 hours without refueling. At the same time, it needed the speed to intercept and destroy enemy bomber formations on their approach. This had to happen long before they could drop their bombs. The engineers quickly realized that meeting these demanding specifications would require a massive airframe powered by twin engines. A standard single-engine day fighter simply would not cut it. Around the same time, the United States Army Air Corps also took a strong interest in the concept of a dedicated night fighter. Lieutenant General Delos C. Emmons, a senior United States Air Commander, happened to be in London. He attended a classified briefing on the latest airborne intercept radar technology. He also witnessed the devastating night raids firsthand. The British had been developing radar systems since 1936. By 1940, British scientists were already actively testing the first airborne radar units. The major breakthrough was that these units were compact enough to be mounted directly inside an aircraft. This gave crews the unprecedented ability to hunt down and intercept enemy bombers in total darkness. They no longer had to rely entirely on ground-controlled interception. In the summer of 1940, the American general returned to the United States. The military then got serious about drafting requirements for a completely new category of aircraft. This was the purpose-built night fighter. By that fall, the first preliminary list of requirements for this type of aircraft had already been drawn up. A pivotal meeting took place on October 21, 1940. Air Material Command Representative Lawrence Craigie met with Vladimir Pavleka, the head of Northrop Research Center at Wright Field. Interestingly enough, Pavleka was at the base purely by coincidence. He had come to sort out issues on a completely different project. The military informed him that the Army Air Corps was in desperate need of dedicated night fighters. However, they did not breathe a word to Pavleka about their plans to install top-secret radar on the aircraft. They simply gave him a vague hint that the pilot needed some way to see and identify other airplanes in the pitch black of night. The very next day, Pavleka sat down with company founder Jack Northrop. They needed to hash out the technical requirements he had been given. Northrop immediately compared the United States military request with the British Royal Air Force specs. His team had already been studying these for over a month. They got right to work. On November 5th and 6th, 1940, Jack Northrop and Vladimir Pavleka headed back to Wright Field to pitch their concept. And notably, at the time, no other American aircraft manufacturer had even attempted to design a dedicated night fighter. The only exception was Douglas. They had just started working on a dedicated night fighter prototype of their own. Northrop's early design for the aircraft was highly unconventional. It featured a long, central fuselage flanked by two massive engine nacelles. Housed inside each nacelle was a huge, 18-cylinder air-cooled radial engine. Specifically, it was the Pratt & Whitney R2800 Double Wasp. These nacelles extended aft into long tail booms that tapered toward the rear. Each boom supported its own vertical stabilizer and rudder. To tie the whole structure together, a large horizontal stabilizer and elevator bridged the gap between the two tail booms. Inside the central fuselage, the designers housed the cockpit, the radar equipment, and two heavy gun turrets. The aircraft was designed for a crew of 3. This included a pilot, a forward gunner, and a radar operator who also doubled as the rear gunner. The firing positions were located at the front and rear of the aircraft. Each turret was armed with 4 50 caliber Browning M2 machine guns. To improve landing safety, they equipped the fighter with tricycle landing gear. This was still pretty advanced for the time. The projected empty weight of the aircraft was 16,245 pounds. It had a maximum takeoff weight of 22,654 pounds. Its dimensions were just as impressive. The airplane stood 13 feet 2 inches tall. It measured 45 feet 6 inches long and had a massive wingspan of 66 feet. This sheer size and heavy weight were much more typical of a medium bomber than a traditional fighter. As development progressed, the design was continuously refined. It went through quite a few structural changes. The engineers even considered a few alternative layouts. This included a design featuring a single vertical stabilizer. By November 14, 1940, Northrop brought a revised design to the military. This time, they decided to completely ditch the tail turret. In its place, they mounted fixed, forward-firing 50 caliber machine guns. These were placed in pairs along the lower section of the fuselage. On top of that, 4 more of these 50 caliber guns were mounted in a brand new powered dorsal turret. Because of these changes, the crew size bumped up to 4. Now the airplane would carry a pilot, a radar operator, and 2 aerial gunners. And the radar itself, the literal eyes of the fighter, was relocated to the very nose of the aircraft. This was done to give it the best possible field of view. But the search for the perfect configuration continued. By November 22nd, the design saw another major overhaul. This time, the designers ditched the lower machine guns. This meant they could shrink the crew back down to 3. A pilot, a single gunner, and a radar operator. They completely rearranged the crew stations. The pilot sat dead center up front, while the gunner's position was placed slightly behind and above them. The gunner controlled the top turret using a brand new remote control system. To give him the widest possible field of view, the cockpit featured a special stepped, transparent canopy. Meanwhile, the tail end of the central nacelle was capped off with a large transparent fairing. This gave the radar operator a fantastic view of the rear. It allowed him to defend the aircraft himself if an enemy tried to bounce them from behind. The top turret was designed so it could lock into a fixed forward firing position. This meant the pilot could actually fire the turret guns himself during an attack. To make the fighter even more lethal, military leaders from the USAAC suggested scrapping the lower machine gun turret entirely. Instead, they decided to pack in 4 heavy 20mm cannons. The plan was to mount these in pairs directly in the wings. The War Department officially issued these requirements to Northrop on December 5, 1940. Taking all these new requests into account, Northrop's engineers rolled out an updated design given the company designation as NS-8A. By December 17, 1940, the government had already signed a contract with the company to build 2 full-scale experimental prototypes. On top of that, the company had to create 2 scale models for rigorous wind tunnel testing. A pretty solid chunk of money for the time was set aside for all this development. Just under $1,367,000. The final paperwork was signed in January of the following year. That was when this new design officially got its famous Army designation, the XP-61. To improve handling and tighten its turn radius, the wings were fitted with special leading-edge slats and zap flaps. These were developed by the company's brilliant engineer, Edward Zapp. The main goal behind this innovation was to significantly increase the wing's maximum lift. These flaps also brought the landing speed down considerably. This gave the pilot much better control over the heavy fighter. Once they got the green light, the Northrop team wasted no time starting work on the first prototype. The design looked so promising. By the spring of 1941, the military had already ordered a pre-production batch of 13 aircraft under the designation YP-61. These airplanes were meant for real-world operational testing in the field. Meanwhile, one extra airframe was built specifically for destructive structural testing. However, the road to creating the ultimate night fighter wasn't without its hurdles. In March, the Army-Navy Standardization Committee suddenly issued an order. From then on, every single aircraft engine had to use updraft carburetors as standard equipment. This decision sent the Northrop team scrambling. The issue was that their XP-61 had been designed from the ground up for a completely different setup: engines with downdraft carburetors. Redesigning the engine nacelles to meet these new standards would have cost the team at least 2 precious months. Luckily for the project, the committee walked back that decision just in time. The schedule stayed on track. The heart of the first XP-61 was a pair of massive 18-cylinder, air-cooled Pratt and Whitney R2800 engines. Each of them produced 2,000 horsepower on takeoff and came equipped with 2-stage mechanical superchargers. Later on, the engineers concluded that in actual combat, turbochargers simply weren't worth the added complexity. Those systems could have boosted the fighter's top speed by nearly 50 miles an hour. They could also have raised its service ceiling by 10,000 feet. But the XP-61's performance without them was already well within spec. In the spring of 1941, a full-scale wooden mock-up of the new fighter was officially presented to military leadership. After taking a close look at the design, engineers and the brass made a few changes. They decided to pull the heavy cannons out of the wings. Then they moved them down into the lower fuselage. To keep the aircraft hidden in the night sky, they added special flame dampers to the engine exhausts. They also slightly rearranged the radio equipment. Moving the guns was actually a huge plus for the fighter. It made servicing the weapons a whole lot easier. It also seriously improved the wing's aerodynamics. On top of that, getting the cannons and ammo cans out of the wings freed up space for extra fuel. Thanks to this, the internal fuel capacity jumped from 540 to 646 gallons. This fuel was now stored in 4 reliable, self-sealing fuel tanks. It even opened up the option to carry drop tanks under the wings for long-range flights. Naturally, all these design tweaks, especially reworking the gun bay, cost the development team some time. The schedule was pushed back by over a month. However, the final result was well worth the wait. For the new XP-61, they decided to install a highly advanced airborne intercept radar system. This system was built specifically for air-to-air combat. The radar mounted on the first prototype was a heavily upgraded version of earlier designs. These designs had already been successfully flight tested on a modified Douglas B-18 bomber. The development of this highly sensitive equipment in the United States was tightly controlled by the National Defense Research Committee. They handed the project over to a specialized lab at the Massachusetts Institute of Technology. The team worked around the clock. By mid-June 1941, the scientists wrapped up the preliminary design for a radar built specifically around the constraints of the XP-61 airframe. Interestingly enough, it was based on British centimetric radar technology. Once development was successfully completed, the system was handed over to Western Electric for mass production. This new radar system featured a powerful search transmitter housed right in the nose of the aircraft. It could spot enemy targets from up to 5 miles away. But the radar was truly multifunctional. It worked perfectly as an airborne beacon and aided the pilots with navigation. It also acted as an identification friend or foe system during formation flights. During a night engagement, the crew operated as a single, cohesive unit. The radar operator on the XP-61 would spot the target first and call out the exact heading. Meanwhile, the pilot flew the intercept, relying on specialized instruments mounted dead center on his panel. When it came to firepower, the upper turret on the XP-61 could be remotely controlled and fired by any member of the crew. The operator could traverse the turret 180 degrees to fend off enemy fighters coming from behind. They could also elevate the guns almost straight up to 90 degrees to fire at targets passing overhead. The forward-firing nose cannons, on the other hand, could only be fired by the pilot. In the summer of 1941, construction of the first XP-61 prototypes was underway. But it was not without major hurdles. Northrop engineers ran into a serious issue. They found it almost impossible to securely mount the special ring for the upper turret to the fuselage. The designers decided to try a different approach. They used a massive pedestal mount, very similar to the one found on the B-17 heavy bomber. Sourcing this part from subcontractors, however, proved impossible. The reason was simple. Those exact same turrets were going into the B-29 Superfortress in volume. That ambitious project took a much higher priority for the military brass than the XP-61 night fighter. Ultimately, in the fall of 1941, the design had to be reworked yet again. They reverted to the ring mount, which was now being manufactured by General Electric. The plan was also to equip the aircraft with an advanced centralized fire control system. This was nearly identical to the one on the B-29. But when the time came for initial testing, the system simply was not ready. The manufacturer could not deliver it on time. They were backlogged with other higher priority orders. Because of this, a basic dummy turret had to be temporarily fitted on the first prototype. Supply chain issues continued plaguing the project. In February 1942, Curtiss officially announced that they would be unable to deliver the new four-blade, full feathering propellers in time. These massive props, measuring 12 feet 2 inches in diameter, just could not be delivered for the initial assembly of the first prototype. They were also not ready for the start of the early test flights. The engineers had to scramble for a quick fix. So the prototype initially flew with propellers of the same diameter, but made by a different manufacturer, Hamilton Standard. Due to all these endless logistical delays, technical redesigns, and parts shortages, the first fully completed prototype of the XP-61 night fighter finally rolled off the assembly line. This happened at the Hawthorne plant on May 8, 1942. Picture this. On December 24, 1941, before the first prototype was even assembled, Northrop was already signing a contract. They agreed to build 100 production P-61 aircraft and supply all the necessary spare parts. The military's appetite was growing rapidly. By January 17, 1942, they ordered another 50 aircraft, and on February 12th, the order was expanded by another 410 airframes. Out of that batch, 50 were slated to go to the British RAF under the Lend-Lease program. However, this part of the deal was later canceled. On that same day in February, the company also received a preliminary order for a staggering 1,200 P-61 fighters. Meanwhile, work on the prototype, designated the XP-61, was in full swing. Throughout development, engineers were constantly making changes, causing the aircraft's weight to steadily climb. When the prototype was finally ready, its empty weight was over 22,390 pounds. Fully loaded, its maximum takeoff weight reached 29,670 pounds. Ground testing kicked off almost as soon as the aircraft rolled out of the hangar. On May 21, 1942, the XP-61 prototype lifted off from Northrop Field for a brief initial hop. It was powered by two massive Pratt & Whitney R2800 double Wasp radial engines. The full maiden flight was logged 5 days later on May 26. At the controls was the company's chief test pilot, Vance Brees. After touching down from the 15-minute flight, he enthusiastically told company founder Jack Northrop, "You built one damn good airplane." Visually, this first XP-61 looked menacing. It had no camouflage, gleaming in a bare metal finish, accented only by bright yellow engine cowlings. On the avionics side, alongside the advanced Western Electric Airborne Intercept radar, the prototype was loaded with additional radio gear to ensure reliable communication and navigation. So what did the flight tests reveal? Performance was truly outstanding. The takeoff speed for this heavy fighter was just 75 miles per hour. It had a landing speed around 80 miles per hour. In level flight, the aircraft easily reached a top speed of 370 miles per hour. This was at an altitude of 29,900 feet. To get airborne, it only needed a takeoff roll of 1,500 feet. Climb performance was just as impressive. It climbed at 2,000 feet per minute and passed the 20,000-foot mark in only 9 minutes. The fighter's service ceiling was 33,100 feet. Range was equally strong. It had a range of roughly 1,450 miles. Test pilots also praised its handling characteristics. They noted that the aircraft could be intentionally put into a spin and recovered with minimal effort. However, after those early promising results, engineers ran into a series of serious issues. These problems significantly delayed full-scale production of the XP-61. The flight controls turned out to be a major headache. Initially, the design team decided to omit conventional ailerons. They installed experimental zap flaps instead. It quickly became clear that these did not provide adequate roll authority. Moreover, the mechanisms proved far too expensive and incredibly complicated to manufacture. A new solution was needed fast. The problematic mechanisms were replaced by 4 conventional flaps, 2 inboard and 2 outboard. They also added small traditional ailerons. To sharpen lateral control, engineers installed the Northrop retractable aileron system on the wings. These were essentially small plates that deployed from the top of the wing to spoil the lift. This design choice became one of the most successful innovations in the entire P-61 program. Combined with the conventional ailerons, they provided excellent roll authority. This was true even at near stall speeds. On top of that, in mid-June 1942, an entirely new horizontal stabilizer was designed for the aircraft. Despite these temporary technical difficulties, on May 25, 1942, Army Air Forces leadership and Northrop agreed on some highly ambitious plans. The initial idea was to produce 1,200 P-61 fighters. This would happen at a massive government-owned plant in Denver, Colorado, which would be leased to the company. But the production numbers didn't add up. By the end of July, this massive order was slashed to just 207 aircraft. Ultimately, it was decided that Northrop would simply build this batch on its own. They would do this at their facility in Hawthorne, California. The first YP-61 was delivered to the military on August 6, 1943. By September of that same year, the Army Air Forces had received the final aircraft from this batch. The total cost of the contract set the United States government back a hefty sum. It cost $64,958,400. On the outside, these pre-production aircraft looked a bit different from the earlier XP-61 prototypes. The main change was hidden inside. The engineers decided to completely upgrade the power plant. Instead of the previous Pratt & Whitney R2800 double WASP engines, the new aircraft were fitted with a newer, more suitable version of the same power plant. During the initial flights of the YP-61, a serious problem emerged with the dorsal gun turret. Every time the gunner elevated the barrels or traversed the turret, it caused severe tail vibration. This was a phenomenon known as buffeting, which severely compromised flight stability and safety. This flaw turned out to be so critical that the designers seriously considered just removing the turret from the aircraft entirely. To fix the problem, a few different ideas were proposed. For example, installing small aerodynamic deflectors right above the gun barrels, removing half of the machine guns, or simply reinforcing the turret structure to make it much stronger. The simplest solution seemed to be locking the turret in place. This made it completely fixed so it could only fire straight ahead along the aircraft's center line. On a few YP-61s, the designers actually did leave just 2 machine guns in the top turret. However, they only managed to get rid of the dangerous buffeting for good on the first true production variant of the fighter, the P-61A. And they did it in the most radical way possible. They just completely removed the dorsal turret. At first, the YP-61 was not even equipped with an airborne radar. But the military planned that by the time the P-61A model went into full production, engineers would successfully finish their work on the new SCR-720 radar. This was a significantly improved and much more powerful version of the older SCR-520 system. Since this aircraft was built specifically for night operations, all the YP-61 fighters were painted in a deep matte black. That menacing look is exactly what earned it the name Black Widow. These aircraft ended up serving in a variety of roles. Northrop retained 2 YP-61s for themselves. They used them as flying testbeds for further trials and for training mechanics and ground crews. A few other aircraft were flown over to Wright Field, where they went through rigorous Army testing. Throughout October 1943, the rest of the fighters were sent down to sunny Florida to the Orlando Army Air Base. There, they filled the hangars of the 422nd Night Fighter Squadron. Interestingly, despite their menacing appearance and combat-ready design, all of these aircraft served exclusively as trainers. Not a single aircraft from the YP-61 series ever saw actual combat.